Hello everyone, my topic for today is Flyweight design pattern. Let's start with the introduction. Flyweight design pattern is a structural design pattern, also known as cache. We use it when we create large number of similar objects. So instead of creating a new object in memory again and again, we try to reuse the object that has already been created for us. This is why we also call it cache because we are storing the objects already been created in the memory and we do not make a new object if we can reuse it. Now, structure of flyweight object. A flyweight pattern object has two parts, intrinsic and an extrinsic part. One where we which is not shareable in all the objects and the other which is shareable in all the flyweight objects. When a client creates the flyweight objects, it doesn't directly create it. It asks the flyweight factory to create a flyweight object so that we do not create an object which has already been created. And Flyweight Factory takes care of it. This is why we also use factory method with this flyweight because subclasses are responsible for creating instance of new classes. What is the motivation behind flyweight principle? When we use flyweight design pattern, we can make the program run a bit faster because object-oriented systems are known to be a bit slow. And when we use flyweight design pattern, we reduce the number of objects that are being used in the system, which improves the efficiency. For example, in a bubble shooter game, we have a number of bubbles. It could be thousands, it could be more than 10,000, we don't know. They're all of same size, but they're of different colors. Now, if we create a new object in memory for every single bubble, we will run out of it and it will make the program slow. Instead, what we do is we create a bubble with some size in the memory. Every time we need to show it on the screen, we give it a different color and show it. So we do not create it again and again. Instead, we reuse it. Now, what is the applicability of flyweight design pattern? It is generally applicable when we use large number of immutable objects because they have a common internal trait, extrinsic part, and some part which can vary, intrinsic part. For example, in the bubble shooter game, the common internal trait was the size, and the part which could vary was the intrinsic part, was the color, because the size was already always same for each and every bubble, and the color was different. So instead of creating a new object every time, we reuse the object that has already been created for us. In real life examples, Candy Crush or Angry Bird, some games, these kind of games, we try to reuse the objects. For example, in Candy Crush, there are thousands of candies. It's not reasonable to create a new object every time. So we create a candy first, then we reuse it by giving it a different color. I created a flyweight program to show the difference between time taken when we use flyweight design pattern and when we do not use it. So I have two classes, owl and unshareable owl. These are just to show the difference between flyweight design pattern and uh, when we do not use that design pattern. I have owl factory, which is responsible for creating objects. How we store a hash map. We have a hash map with color as keys. So we check if an oval of green color or if an oval of any color has already been created. If it is already in the memory, then we return the same oval. If it's not created, we create a new one. Now, draw ovals is it's a class which helps us draw ovals as it's clear. And I have methods where I'm drawing with flyweight and I'm drawing it using without flyweight method. Now let's try and run this in our driver. As you can see, I created 10,000 ovals using each design pattern, and then I calculated the time. And you can see that when we use flyweight design pattern, it is faster than the ovals created when we do not use flyweight pattern. It shows the efficiency of flyweight pattern and why we should use it. Thank you.